People people already attended. So with that, I'll go ahead and get started. Thanks so much for Andy and Jennifer from Inbalance Green Consulting for being here with us today for part 4 of our all-electric design and construction series on ventilation and HRV. Thanks. Okay, before we get started, just a few quick Zoom reminders. Please make sure you are on mute for the duration of the training. If you have any questions, and we really encourage questions, you can either add them to the chat or you're welcome to raise your hand and then we can invite you to speak. This session is being recorded. The slides and recording will be shared with you within the next few days. If you don't get them by maybe Tuesday of next week, I'd recommend reaching out. And then also very importantly, we will be using Zoom attendance today to distribute the ZNCD and AIA learning units. If you want to receive these learning units, please make sure that you have registered for this event and that you've provided your AIA number if you want those learning units. And also that you are joining today from the Zoom link that was sent to your email when you registered. If you're joining from someone else's Zoom link or someone else's screen, or you've called in, I won't be able to see that you've attended for today. So you have to make sure that you email me to get attendance recorded properly so I can make sure you get your ZNCD and AIA learning units. If you have any questions about this or worry that you may not be getting your attendance kind of correctly, go ahead and email me and I can look into it for you. I'll be adding my email to the chat shortly, and it will also be included in the slides when those are distributed. The AIA learning units and ZNC certificates were distributed for parts 1, 2, and 3 of this training. If you haven't received those, please let me know and I can look into it for you. I know many of you have tuned in for the previous trainings in this series, but for anyone joining us for the first time today, I will quickly share a bit about who we are. We are the Tri-County Regional Energy Network, aka 3C-REN. 3C-REN is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these dollars back to our local economy, which has historically missed out on some of these funds. Thank you. 3C-REN currently offers 6 programs focused around 3 services. These include incentives, training, and technical assistance. This training series today is a part of our Building Performance Training Program. You can see additional trainings being offered through BPT and learn about the other services that we provide by visiting our website, 3c-ren.org. You can go to the next slide. Thank you. Since 2019, 3C-REN has had over 4,000 individuals attend trainings, answered 334 Title 24 and Cal Green questions. And if you are not sure what this is about, we'll be, either Andy or Jennifer are going to be sharing more about Code Coach at the end of this presentation. So make sure you stay tuned. It's a really awesome service that is probably really applicable to a lot of the people tuning in today. We have also secured $155 million for investment in the Tri-County region and have completed over 1,000 energy saving projects. Everyone at the 3C-REN team is really excited to continue growing in all of these areas in 2025. And with that, I'll be handing it over to Jennifer and Andy to start today's training.
Thank you so much, Chloe. It's always super fun to partner with 3C-REN and their enthusiastic seasoned professionals. So this does meet the both an AIA Health, Safety, Welfare Learning Unit and the state of California architecture licensure requirements for zero net carbon design. And so for those who are wanting the ZNCD, again, this is self-reporting. So the AIA 3C-REN will report it directly, but the ZNCD, they'll provide you with a certificate, and then you can include that as part of your licensure. Check the box that you have it, and then be ready with the paperwork in case there's an audit. Next slide. So this is part 4 of 5 for the ZNCD series. So Jennifer has been with you all along. I was here for the first one. Grant Murphy was with the next 2. I'll be here with you with Jennifer today. And then Tatiana Soglin will be joining Jennifer for part 5. All of these have been, they're recorded, but you don't get the learning units unless you listen to it live in person. So here's the learning objectives. And as a reminder, we will send you the slides. So these have a lot of information, the slides, so don't worry. A lot of it is we want to kind of make some introductions and then provide the details in the slides for your reference. So today we're going to very briefly provide that context in terms of the zero net carbon design. I'll provide an overview of kind of what our approach is about ventilation for indoor air quality. And then Jennifer will go into a closer look for those strategies, and then finishing up with some lessons learned for client expectations, and then just tips and tricks for aligning with Title 24. So zero net carbon design and California's clean energy goals, that's what's triggering this requirement in the first place. And as Jennifer mapped out in the first session, California's got a plan, and within the built environment, it's energy efficient buildings that don't use as much energy, and that the energy that they use is going to be carbon free, right? So renewable energy, either on site or part of a carbon free electric grid. So it doesn't do any good to do all electric if we're using a lot of carbon to make that electricity in the first place. So that's the goal for the buildings. And then, of course, industry and transportation as well, moving towards all electric and energy efficient. And within those big picture goals specific to the energy code, both 2022 and then the 2025 updates, which we'll be hearing about all year, and since they'll take effect in January 1st of 2026. So kind of the main things that you'll be seeing and have been seeing is heat pumps, both for heating, cooling, but also for water heating. Electric ready requirements for those single family homes. So if you still have gas, you got to be ready for electric. Expanded PVs and battery storage requirements to help with that grid stability. And then that last point there, strengthen indoor air quality ventilation standards. So better, tighter buildings. We're finding that we need to continue to evolve the ventilation. So just a few slides to kind of set that context for ventilation. Super basic, we need fresh air, and the reasons for that, right? Materials that off gas, whether it's construction materials and all those cleaners, toiletry items, packaging or furniture, carpet, clothing, cooking in general is going to have some off-gassing, but there's definitely, we're finding that gas cooktops off-gas even more than we realized. And then we have infections and general air quality that way. So great ways to provide fresh air, still number one, open a window when all the circumstances are just right. And when we think about resiliency, being able to have fresh air is terrific, but it's not going to be applicable all the time, right? If you have the heater on or air conditioning or passive heating or cooling and you're shutting your house to retain the temperature that it is, or as we often find in California, that the outside air quality is bad. You'll want mechanical ventilation, or more specifically, you'll need it because that's what the energy code says. So either way, it's a good practice. So when we think about fans, and they're doing different purposes, right? So there's exhaust for bathrooms and kitchens, dryers. We're exhausting garages, workshops, industrial spaces to get whatever we produce in the space out. There's fans for radon mitigation. There's whole house fans or other strategies for temperature control. And then there's outside air ventilation. So we're either pulling outside air in or pushing in the outside air, or we're doing both. And so that's our macro approaches to fans. And the reason why this is timely and part of this conversation, right, is that in the we are accustomed in a commercial setting that you would have an air handler, and there's heating and cooling and air, and you're putting it into ducts, and it's all one system. But increasingly what's happened is that we have all electric mechanical equipment for heating and cooling, and it's sending around refrigerant. So it may or may not be part of a ducted system. They're super efficient, but they might not have air. They might be heating and cooling only. So, and our buildings are themselves, the envelopes are more efficient, right? So we've got a lot of insulation, we've got tighter envelopes. And so having, we don't need as much heating and cooling, and our buildings aren't letting in willy-nilly fresh air in the same way that they used to. So that's a good thing in terms of energy efficiency. So the diagram on the left is showing you a heat pump, and that has all kinds of way to distribute heating and cooling, but not necessarily air. That's a separate kind of system. The one on the right you've seen a couple of times, where we're talking about the variable refrigerant flow, VRF heat pumps, and the solar panels. And this time Jennifer is also pointing out that there's a dedicated outside air system, a DOAS. So with that kind of how we introduce increasingly our outside air is that it may be appropriate to decouple with the heating and the cooling, so that we're rethinking our ventilation strategies. So in this case, you can see in the top that there's a dedicated outside air. It brings it in, and it's linking up to, and it's a little hard to see on the slide, but there's some little orange lines that indicate the refrigerant. So they're going into a recessed cassette in the ceiling that's delivering heating and cooling, and then or into a ducted system. And in the top one, the outside air kind of becomes a part of that system. And so it's ventilated, bringing in outside air that way. Or the bottom one is a separate system altogether. So you might be running fans at a time where you don't need the heating and the cooling at all. So these are kinds of approaches to systems, depends on, your climate, the uses, the application, et cetera, but bringing in outside air in that way. And kind of going to the residential, small commercial types of scale, multifamily, is that the fans that we're looking at are going to be, our exhaust fans, as we've talked about, supply fans, a whole house ventilation kinds of system where you have exhaust and supply. And then want to differentiate that the left three are all for ventilation and indoor air quality, whereas the one on the right, a whole house fan, that is for cooling. And so on the next slide, we're not going to talk about it anymore after this, but I do want to make sure that because it comes up in the language a lot, is that a whole house fan is the kind of thing that you would turn on for 20 minutes and it vents the whole house, and it's a terrific thing, but it doesn't provide the ventilation requirements for indoor air quality. But it is part of a prescriptive minimum for some climate zones, including climate zone 8, which I think is down in Ventura County.
Nine
Is Ventura. Thank you. So those climate zones, this might be a prescriptive baseline. So you might be seeing them in a lot of projects in those parts of the state, but just know that that's a different thing than the ventilation standards that we're going to be talking about a little bit more. So again, just to make sure that we're on the same page in terms of what's required and what are some more energy efficient ways to move through this and improve indoor air quality. Code minimum, you can be met with exhaust only. And so this is the type of thing you might have a bathroom fan. It's exhausting at a kind of a high level when there's humidity, but the rest of the time it's running at a really low level or cycles on and off throughout the day to provide continuous code minimum level of air changes. And then you can also do the same thing, but in reverse, where you're taking a direct supply and then it's pushing it out. So either way, you're kind of relying on the leakiness of the house. The one on the supply only is a little bit better because you can be focused where the air is coming from versus an exhaust only, which might be pulling in from the crawl space or the garage or something that maybe isn't built quite as well. So then the next level up would be to have a balanced ventilation. So you have a supply and an exhaust. Again, you'll still need exhaust for your bathrooms and kitchens, but this is could be an integrated system in order to have the same amount and having control. And then the best would be is if you also have a heat recovery ventilation system, so that you're bringing in the outside air, but you temper it with the exhaust in order to have that balance and a good temperature. Jennifer will get more into the specifics of the heat recovery ventilation, but just to kind of recap on what we're doing there is that if you have very cold outside air and very warm inside air, then they cross each other on the way in and out. They don't actually cross each other. There's just fins, but it makes a big difference. So you're bringing in the fresh air, but it is tempered either for the cooling or the heating. So that's the overview of what we're trying to do. And then we're going to turn it over to Jennifer to take a closer look at those strategies and give you some more information. And I'll keep an eye on the chat and flag Jennifer for answers when we need them. So thanks.
Sandy, welcome everybody. And yes, please do put your questions in the chat and Andy will answer them or interrupt me and then I'll answer them. And part of that kind of big picture view is all these strategies are needed for every occupancy type. But today we do focus a bit on the residential scale because it's easier to maybe kind of understand how all of it's working. The other thing is that as architects, you have more influence over the residential scale or really small commercial as opposed to non-res projects and even multifamily projects where you most likely have a mechanical engineer who is designing the system. But to understand conceptually what systems are out there and why you need them, and also to have a better idea of, as a designer, what types of pieces of equipment are you needing, like on the ground or up on the roof, to provide the outdoor air ventilation. When we look at kind of that residential scale, though, there are many options and many brands, and they cut across everything that Andy said, with it being like exhaust only type systems, supply only type systems, balance systems with supply and exhaust in the same system, or systems where it's integrated with energy recovery or heat recovery, which it could provide a Title 24 energy compliance credit for colder climates. Don't see it so much with the mild climates. But also what we're seeing more and more is that with homes that are being like have extensive renovations or remodels, or really like small ADUs or small ADU additions or small bedroom additions, room additions, spot ventilation can be very handy. And so this is an example, one brand of distributed spot ventilation, where this particular system has a core that Mike Corrigan, this is current construction, he's installing these for a project he was building, and there's a ceramic core in there. He's saying kind of the same thing. Sorry about the sound. I don't know why I don't have sound on the video right now. But a small fan, a ceramic core, and these things work in pairs and they connect with just a low voltage line to a controller. And as one set of fans turn on, it pulls air in while the other set turns on and exhausts the air. And then it reverses so that the heat exchanger heats up when the airflow flows one way. Say you're in heating mode, as the exhaust air is sent out of the house, it's heating up that ceramic core. And then when the fan reverses, the cold air comes in, but it's preheated by that ceramic core that it passes through. And it provides ventilation to the house. It's very low CFM, 20 CFM per pair. And they do come with small filters for the outside. But that's one type of system that we're seeing becomes quite popular. And you still need your regular exhaust fans for your bathroom and kitchen hood. And then the other type of system, kind of on the other scale of complexity, is a whole house ducted ERV. So this ducted system includes home runs to the heat exchanger and that fan unit, which is typically installed in a mechanical room or in the garage. It's sealed, so you're not introducing any air from your garage into the system, but it's a place where you can locate it to access filters and do maintenance. And it requires a series of manifolds. From there, you branch off with 3-inch ducts, and it can be distributed throughout the house. And it includes supply ventilation, exhaust ventilation, and return air ventilation. Inside these systems that have the heat exchanger, then, like Andy was explaining with that other slide, conceptually, like air comes in, air goes out, the heat or the energy, when we say energy, it's heat and some moisture is transferred. The air streams never touch, but the heat can readily transfer through the medium. So if one airstream is cold, it's going to absorb the heat from the warm airstream. And that's how the air is tempered as it comes in and out of your house. What that kind of, to demystify it, even if it looks like the Zender covered in a sort of a smooth plastic shape, most of these systems, residential scale, are just housed inside a metal box. But you take that off and look inside, and what you're going to see is air intake, air exhaust connections. And you're going to see an ECM motor with a MERV 13 filter on the air intake. That MERV 13 is part of the Title 24 requirements, and that's a filter that can be easily changed and replaced. And then you're going to have another ECM motor for pulling the return air in. And it's also going to have a small MERV 7/8 filter on it just to protect the heating, the HRV or the ERV core. And then that core is a cube for the residential size. It's about 5 inches by 5 inches or so. And that cube, maybe it's a little bigger, 7 inches by 7 inches. It's not really huge, but that core has tiny little channels in it where that energy can easily transfer through the airstream. And then these air paths cross. And this concept is the same concept in some of the really large scale DOAS systems used in commercial projects or non-single family residential, where they might have an extremely large core like that, or it could be in the form of a flywheel, and that flywheel rotates, and sometimes the flywheel is only like 3 feet in diameter, but some of them for large systems are as tall as I am or a little bigger than that. for an architect who is wanting to get a handle on what is needed for your residential project, or let's say you're working on an ADU. You might have a 500 square foot ADU, 1 bedroom, and you're trying to figure out, oh, do I need should I do a bathroom fan, or should I bother with one of the HRV, ERV products? Trying to get a handle on that. I included this slide here so that you can at least calculate what is the ventilation needed. And then I just gave some examples in the spreadsheet for you where I went ahead and said, okay, let's pretend we've got a 500 square foot ADU and it's 1 bedroom or studio. We would need 30 CFM of outside air. And then from there, you can start to look at the type of equipment you need. And a bath fan that's qualified to bring in your outside air as an exhaust only system would qualify, but also there's some other products we're going to go through that would meet that CFM. And then let's say you had a 1,800 square foot house with 3 bedrooms. Now you're needing up to 84 CFM for outside air. And now you're going to be looking at like multiple fans, or perhaps if you want the energy savings, you would go with the ERV or HRV. And then the prices vary depending on that type of system. But as architects, you have some control over that and what you might put into your project. And then just as a reminder, for new construction, you'll have a HRV rater be part of the permitting process that will come out and actually measure or look to see that the outside air requirement is met. With additions, alterations, and such, you can introduce outside air and introduce all these concepts, and you won't necessarily have to have someone come out and verify that it was met. But part of the next step in this is knowing if you need that Title 24 verification requirement, such as for new construction. Then you're going to be looking for products that are HVI certified, and they're required for your kitchen hood range fans, your bathroom fans, but also for your dwelling indoor air quality, ventilation, and flow rate. So you could go to the Home Ventilating Institute, HVI, and have a list of those products that are available and see which ones are there that California allows for Title 24. So HVI.org takes you to their homepage, and then you can click on the HVI certified products directory. Section 1 is going to give you your bathroom fans and your kitchen exhaust hoods, but it's also going to be the place where you can find the inline fans for like supply only. So
a question came in asking about the efficiency of ERVs, HRVs, if there was kind of a minimum efficiency, or how that kind of works within the selection process. I don't know if you're going to talk on that specifically as you go through some of the different options.
I will touch on that. And but kind of the short answer for right now is 65, 66, 67%. That range is kind of your typical range. If it gets less than that, it's probably not a product you want. But also, the higher the efficiency, the higher the price. And our climates in our Tri-County region are not that extreme. So I'll also kind of touch on that. Sometimes you want higher efficiencies because you're needing that Title 24 credit. So there's a couple climate zones in Ventura that might benefit, but like San Luis Obispo area, doesn't matter so much in terms of Title 24 credit.
Right. Thank you. There's another question about when to when to select what system, but I think we'll save that for a little bit later. 'Cause
Okay.
it's a bigger conversation, and now we're getting into some of the equipment specifics.
Okay. And then some of these same things really apply big scale and small scale. And so Section 3, this is where you have your energy recovery ventilators or heat recovery ventilator systems. And there's about 41 brands listed. So many to choose from. Most of them are HRV or ERV, meaning heat recovery or energy recovery ventilation. And then there's one brand now that's called a compact air treatment unit. And it's called a treatment unit because it includes heat pump air heating to temper the air, but also it has a mechanism for dehumidification. So it's really doing more to treat the air. And I just saw in the recent literature that Daikin, for example, is now offering compact air treatment units, but I don't know yet if they're rated or small enough to be on the HVI certified brands. I did not see it when I just checked, but just kind of put it out there that more and more brands are going through the testing. So this list is expected to grow. When we're talking about the kind of starting with the residential scale, and again, this could apply to commercial projects or something larger, is just that in many cases, this isn't, would not be cost effective to do it this way. For example, exhaust only ventilation. Homes are fairly leaky. You need an exhaust fan already for your bathrooms already. So one of the least expensive ways of meeting the outdoor air quality and meeting your bathroom exhaust, meeting both at the same time, and especially for a small house, you could get a fan. They come with ECM motors, variable speed options now. You can choose the ventilation amount you need with many of them. However, there's no recovery, no ventilation because it's no filter because it's exhaust only. But they're your least expensive. Some fans that qualify are under $100, and you can get them just about anywhere. And then kind of that next notch up we talked about with supply only systems, an inline fan, simple duct runs, like Brown Fresh In. They're showing theirs with ceiling recessed installation with a accessible hatch that can be pulled down so you can get to it, so you can change your MERV 13 filter. If you're doing that for Title 24, you'll need the MERV 13 filter if you're doing new construction. And it's recommended. ECM motors, adjustable, CFM, which is your cubic feet per minute volume that comes in. And these are affordable systems. So a lot of times you'll see folks put these in and supply it to their laundry room, for example, and then combine it with an exhaust so that their laundry room is getting plenty of fresh air when they need it. The spot ventilation or distributed ventilation systems that we showed, there's several types. We showed the Lunos being installed. There's also Twin Fresh is a brand that's now out there. A couple new brands are coming on the market, Pioneer and Fresh R. However, I just want to point out those products are not HVI listed, but they can have important application in existing homes and in additions and remodels where people want to have fresh air that they know isn't being forced to come in through the cracks and crevices of their house. In other words, when we ventilate an existing house or our fresh air on an existing house that doesn't have a system like any of these we're talking about, the fresh air comes in when we negatively pressurize the space, or it's positively pressurized from wind. That wind pushes on your house, and then as it swoops over the house, then it causes negative pressurization on the other side of the house. And so through just the natural weather patterns, your house is getting a certain amount of fresh air through it. But we're asking the insulation in your walls, if it exists, to be your air filters. And then who knows with older houses what all is being pulled in either through the crawl space and up into your house. So if you want to eliminate that, one way to do it is to use these easily installed products that go through the walls or are wall mounted. And a lot of them come with HEPA filters, and the filters are easily accessible, and they can be cost effective for small spaces.
So
Jennifer,
we're having a little bit of chat about kind of just this topic, and specific to when the air quality outside is really bad. And I don't know if I think we maybe mentioned that you should be able to turn off those automatic fans manually to make sure that you're not bringing in smoky air. But in general, heard about like kind of a positive pressure so that you are keeping out the leaks, better air sealing. But just typically, are there some best practices as we think about designing for particularly smoky, bad air quality days?
Yes, there are, but it's none of these products. Everything I'm showing you here is, well, let's say if the air quality is a little bit poor, but we're not trying to deal with really being in the throes of smoke from a fire that's nearby. Some of these, they come with sensors and filters. I'll hit on that it can tell you if you have a CO2 buildup, or tell you if you've got 2.5 parts per million of the air pollutants of a certain size. They've got those sensors in them. But these would be good for like a small, let's say you're doing a small room addition, and you know that you want that room to be able to have the fresh air, or you have a small space, and you want a HEPA filter on it for this new construction, and you don't want your new construction to now have your walls and your other insulation act like the filters to your fresh air. These are great. All of them, by law, and and I haven't seen any that weren't set up this way. They all could be turned off. So bad outdoor air quality, all your fans go off. And then what you'll have, and what some people have been investing in now, is like a portable HEPA filter inside their house that they can operate, that's just cleaning the air that is in their house, as they are trying desperately to avoid introducing the outside air, which is filled with smoke. And then if it's really bad, that's when you need to find another place, to habitat till
Right.
the fire's over.
It seems like at the end, when we're all done, and be able to have some discussion as people kind of share what strategies they're doing as well. So just wanted to touch on that briefly and invite a conversation after we're done.
Yes. And then cost effective, small spaces, is HVI certified. We're seeing a lot of these go in where you recess it into the ceiling, the Panasonic brand, and it is HVI listed. Again, it's for small homes, or you have to have multiple of these units, because the system only, the range is 20 to 50 CFM. It does have for MERV 13 filters, and it's within the same price range as these others for small spaces. If you have really large homes, or you don't want multiples of like the Panasonic type, or multiple exhaust, multiple supply fans, you can do the larger systems that have either extensive duct runs like a Zender type system, which is kind of the highest end pricing, 2 to 3 times higher than like the accessible location style with the simple duct runs on the right. Both have ECM motors, variable speed. They could do much larger homes. They're used in single family and multifamily and light commercial with the style that's on the right. And then it's easy to balance the ductwork on these systems. I'll talk to you a little bit more about each of those as we get through the next couple of slides, but that kind of gives you the overview of spot ventilation versus like whole house ventilation with ERV and HRV capabilities. Okay, so when we're talking about that exhaust versus supply versus balance versus the HRV or ERV, the cost goes up and up depending on, the complexity of the system. The other thing that's really kind of affects the cost of these is whether or not the product's going through some promotional pricing. So I see online quite a bit that different brands at different times are doing sales, or they're putting an older or discontinued model on sale, and then you can get a good price on that. Also, as the capacity goes up, so more air volume, the higher the cost. Also, as the efficiency goes up, typically higher the cost. And also the more, the sophisticated controls, whether they have default diagnostics that alert you to something's wrong, or you have airflow monitoring. Some of them are Wi-Fi enabled, so they've got Wi-Fi smart controllers. There's timers, occupant controllers, CO2 monitors, and then the PM10 or PM2.5 sensors are available in some models to help understand what's going on with the air pollution and whether or not it's time to, change some of those filters. And then the other thing that affects costs, and really you kind of have to look at this in terms of what climate zone you're installing these, is some of them have freeze control shutoffs, and they also have additional inline heaters or humidity sensors. And some of these will even operate to down to negative 14 degrees Fahrenheit. So it, if you're trying to shop for these yourself, those are the things you're going to want to look for, because if you're getting some that operate to negative 14 degrees Fahrenheit, for example, in San Luis Obispo, you're probably wasting money in that case for that more sophisticated unit. And then the warranties really vary depending on the brand. A lot of them, though, have about 5 years for the core, that ERV core and parts, and 10 years for the whole unit, but not all of them. And then the other kinds of things, and I think this is maybe something to look at when these systems are being installed, like the aesthetics of it and just a better quality install and design. So Panasonic, for example, is now making their easy, soffit vent cap, so that when you use their products, the installation is going to look a lot better. And these kind of caps can be used with both the exhaust or the intake. And then some of the other stuff to really consider when you're looking at these systems for the actual installation is whether the ducting is going to be flex or rigid, and you want to I mean, as architects, you don't have too much control over this, but you can go to the job site and you can talk to people and find out what's going on. So for example, restricted or crushed ducting is not going to work well. Plus, it greatly affects the sound that your clients hear and the static pressure, which makes the units work harder if there's too much static pressure. But the one things that they may be interested in as an architect, you do have some control over is how that exhaust termination is going to look and where it's located. So you want it away from your dryer exhaust, for example. And you want the supply intake away from the other, I think I misstated that, sorry. You want the supply intake away from the dryer exhaust, and you also want the supply intake away from the exhaust on the system. And then probably the last thing to really think about is the accessibility to the unit itself, because the balance systems and the supply only systems do have filters, and it makes a big difference if the owner or whoever's doing the maintenance can access those and change the filters. And then when it comes to the filters itself, just kind of a little bit on client expectation is that the filters have a cost to them depending on the brand. So some brands use pretty standard MERV 13 filters, and it's recommended you change them monthly, but sometimes if you're not in a dusty area and there's not a lot of buildup, maybe you only need to change it 4 times per year. Kind of depends on your location. But some of the filters are proprietary, and you might be spending $26 to $53 every time. And again, that's, bulk purchasing can save the clients, but it's better, in my opinion, to keep the cost down to use something that's readily available. Now, when you have an HRV and an ERV, HRV cores typically can be washed once in a while, but the ERV cores, if you do not wash them, typically you only vacuum them. So it's important to kind of have your clients to understand if they get that system, there is some maintenance that needs to be done. The Zender, however, part of why it's maybe more expensive because it also promotes that its ERV core can be washed, which helps homeowners take care of their systems. And then the last thing is just to think about those terminations, because there are bugs and other things that get into the system. You're gonna get a copy of these slides. And so I'm just gonna warn you, there's a lot of kind of categories on these with each of these slides. And I want you to know that you'll get that copy, and this is like a reminder. And I'm going to go through some of the highlights. So again, when you look at like a bath exhaust only, it's less expensive, but the newer models do have pick-a-flow controls. They're HVI certified and Energy Star certified. And you can get these at Home Depot, Lowe's, Ferguson's, and on supply warehouses, etc. Some of them are even now Wi-Fi controlled. Then you go up from there, and then you're into those Panasonic, those two-port, ducted two-port Panasonic ERVs. The efficiencies, we're wondering about that. Depending on the airflow, your efficiency is going to be going anywhere, sensible recovery from 60% to 70%. So that's, it qualifies for Energy Star. And this can be appropriate for small dwellings with low static duct pressure design. This type through the wall, it's on some of its speeds, it's not that quiet. It's 36 decibels. So 1.7 sounds. It's just a little bit out of the Title 24 range for meeting the HVI certification and all that, but this could be really helpful if you want something that's easily installed with a HEPA filter and the PM 2.5 sensor, etc. And then we get into the kind of the whole house ducted systems, professional installs. You can get MERV 13 filters on some of them, HEPA filters on others. The efficiency goes up. And then you might notice that with those two that I show there, the upper one has an efficiency now that's at 75 sensible recovery, as opposed to their other one, it only has a 68 sensible recovery. And then with the higher efficiency, the price goes up accordingly. And then get up even higher, and then you've got the HEPA filters, and like this unit, the price goes up, and now we're up to the 81% efficiency. And then even with that, look for promotional pricing. Sometimes one same CFM, same brand, and one product will be offered at a substantially less price because it's being offered on sale. And with the Zender type of system, this one, you can expect to pay over $4,000 just for the unit itself. But the thing is, with this type of system, it has very high efficiency. It's up to 83%, but they will give you the whole kit. They'll design it. They'll give you all the ducts and figure out everything you need, and it's delivered. So the installation is much easier, and there's someone there who is available to troubleshoot the system for the person doing the installation. And the only way to get it is through your builder and Small Planet Supply. So I put that in there so you can find out more about that system through the Zender distributor. And then just kind of scale up. This is same concept, but this also applies to your multifamily commercial schools, offices, where it's like the whole house ducted system, except now it's scaled up even more, and now it can be ducted throughout the office building or throughout the school, and it can operate independently of the variable refrigerant flow system used for heating and cooling. And then just a couple of tips here for managing some of the client expectations, are also just kind of FYI on Title 24. Little bit review, but you want to ask the homeowner or kind of think this through as you're doing the system for multifamily or for single family. Can the homeowner or the maintenance person easily access the filters? If they can, it's more likely they're going to be changed. If not, then it becomes problematic, because now the whole reason for having good indoor air quality is diminished greatly if the filter's clogged up and not doing its job, and you can't really get the air in there. And kind of remind them that they do have some maintenance with these systems. Same with the heat pump water heaters we talked about, and the heat pump space heating. All of those indoor mechanical systems have some kind of filter, some kind of maintenance, because they want to protect either the HRV or ERV core, or like the fan coils in the heat pumps. And then some of these systems do have more noise than others. And so locating them for some occupants is really important, because they may not appreciate the sound of the fan running at night to bring in like continuous fresh air. And also some occupants notice that the air coming in is cooler or colder than they were expecting, and they don't appreciate the feeling of that being kind of dumped on them in the middle of a hallway, for example, near their bedroom. So I would think about the locations of those. I put this slide in here for you also because it just is a reminder of what your HRV's rater for that visual inspection on new construction is going to be looking at in terms of the filters and where the outdoor intake can be located and some of the requirements associated with it being accessible to people. They are your indoor air quality system, including the local, all your local exhaust is a HRV's inspection, HRV's requirement. And it does show up on the form, so kind of a reminder for that. On your Title 24 form, you got your HRV summary and your indoor air ventilation summary. So that comes up. And then for your multifamily projects, indoor air quality is important. And then there's a few extra requirements that come with it, like backdraft dampers and air sealing to stop the air movement between the dwellings is what they look at. So typically you would do a balanced ventilation, such as this system, where now you don't have to worry so much about the compartmentalization or the difference of air pressure between the dwelling units, because each apartment, each dwelling unit would have its own ventilation, own balanced ventilation. And under the current code, you do the balanced ventilation, or you prove through blower door testing that you're not having leakage between the dwelling units, but only leakage on the exterior walls, which for exhaust only is a good thing. That dwelling unit compartmentalization, that's going to change coming up in the new code, where you're going to be doing that testing anyway. And then last but not least, we recommend that you put on your cover sheet, especially, for the single family ADUs, remind everybody, if you're taking that HRV or ERV Title 24 credit, or, that the HRV and ERV is accessible, that all that goes on that front page to give a big draw attention to it for the builder. And then if you have any questions on any of these things, you can reach out to us through our Code Coach service, and you'll get a copy of the slides. We've got that for you. It's all free to everybody, the general public, architects, builders, you name it. And then with that, I'm going to hand it back over to Chloe. And if there's time, Chloe will let us stay on the line longer to answer questions.
Thanks, Jennifer. We absolutely have time to answer some questions afterwards. So if anyone has any questions and can stick around for a few minutes, Andy and Jennifer will be here to answer them. Before we get to that, though, just a few closing remarks. Firstly, thank you to Andy and Jennifer for a great training today. And we are going to be having the last installment of this series next Thursday. So if you're interested, please tune in for that. A reminder that we are using attendance records from the Zoom call today to distribute your AIA and ZNCD learning units. So if you were worried about your attendance being marked correctly, go ahead and just email me. My email is on the screen now. Slides and the recording of today's presentation are going to be sent to your inbox soon. You might get those in the next 2 or 3 days, so just keep an eye out for those. You're also going to be getting a survey. If you have time to fill it out, it really does help us. And then lastly, we have a few upcoming courses. I already mentioned part 5 of our series today. We also have a green building construction tour in San Luis on the 11th of February. And then of the 12th of February, we have an update for the 2025 Energy Code, which I think will also be really interesting and helpful. We have a lot more trainings on our website. So if you're interested, definitely check it out, 3c-ren.org. And with that, I will hand it back to Andy and Jennifer to answer any questions we have.
Great. Thanks so much, everyone. And I know that this is a lunch hour, so if you need to drop off, we totally get it. And I do want to make sure that just kind of in that looking ahead, the schedule, Jennifer is going to be providing that overview class of the changes to the 2025 Energy Code. But then over the subsequent months, there'll be a little bit more of a breakdown in terms of implementation strategies for ADUs, single family, multifamily, non-res, etc. So just keep an eye out for those so you can get all the great code information that you want and need. And so we did have a couple of questions, and we'll go ahead and maybe stop sharing screen and allow people to unmute. So Jennifer, first there was one observation that early on we have that slide that I think it's from the CEC was my recollection when the that 70% of electricity use is by buildings. And somebody pointed out like, what, really now with all the electric vehicles? And I was like, oh yeah, you know, you're probably right that that was kind of my recollection was that was the CEC putting that out when the 2022 code cycle came out. And in those, you know, just in these last couple of years, 2 or 3 years, that probably has shifted in terms of compared to buildings. But buildings are also more electric. So I don't know. Anyway, I didn't know if you knew offhand, or we'll just kind of track it down for next week.
I'd have to go to the first presentation because I did pull that information, like how much of it is going to the transportation sector, but I don't know if I put it in there in terms of specific electricity use for transportation.
Yeah, it was just a little,
but-
it was a more of a
Yeah.
graphic presentation. So anyway, and then I'm not sure if that's you, Jennifer, who's sharing, screen sharing, if we want to go ahead and or if that's Chloe, but if we want to stop sharing screen and be able to, there was some pretty cool conversation going on about the fire, smoke, how to clean. There was, you had talked about the HEPA filter, and somebody, David, I think had noted that the HEPA filters are great for air quality, but you would need a carbon filter to actually get odors, to capture odors, that might be another strategy. And then there's some other ones as well. So I don't know if David or some nice thank yous in here, or Diane, if there's any folks who want to unmute and kind of have those conversations about ventilation during specific about with smoke and fire concerns.
No, I know this is Diane, and yeah, anything that anyone has to share. I just know that, you know, thankfully it's not all the time, but when we do have smoke events and people, you know, of course, have access to more information now with, you know, some of the apps that tell you what the air quality is. There's a lot of concern about all the things in our houses now and our buildings that work automatically. And I know at work we have a pretty sophisticated, you know, we have like all kinds of resources for people to put in some pretty elaborate filtering systems for sensitive populations. But, you know, for some of my practice outside of my regular job, my moonlighting work, you know, I have a lot of people are like, wow, if I put this in and it's running automatically, how do I shut it off? And, you know, and they, you know, and they're, you know, with some of our houses that are a lot older, people are also then really concerned about drawing air from underneath the house or in the attic, because unfortunately there are little things that live in those spaces that people are kind of panicked by those too. So yeah, if anybody's got some practical solutions for that, that would be great.
Andy, start.
Yeah, I appreciate it, and I think just by the little echo here is the reality is I think you kind of hit on a really important point in terms of manually adjusting something versus what is automatic in those types of setting and changing air conditions. in terms of air quality in particular. So I don't think that I do have anything specific. There was even just the idea of kind of the passive house type of approach where a building is very well air sealed. And then it just seems to me that if you can have really good control and then be able to shut that off for a finite amount of time, and or have it be elevated so that there's sensors that are responding. I was in a model home that Velux, the skylights, had put out, and the skylights were responding to temperature and just CO2. So, which again, we've seen in kind of commercial settings, but it was really lovely to have it in a home so that you're just kind of there with a group of friends. You're not really thinking about it, and you don't have a window open necessarily, and then the skylight opens automatically. So I think that there is some value in that automation piece. So that's just kind of one thought. I don't know if Jennifer, you have something to add. Otherwise, there was also some questions, just maybe some hints on the mechanical for non-residential projects, and the DOAS. Do you integrate the fresh air in with the heating and cooling distribution, or is it better to have it be an independent? And I don't know if there's any hints on kind of how we talk to our mechanical engineers to help us be getting a system that's going to be most efficient, the kinds of questions that we might be asking at that, slightly bigger commercial multifamily kind of scale.
That one is tricky. I would say just have the conversation in general. Ask your mechanical engineering consultant, like, what do they, what's the best approach for both indoor air quality and low energy use, for example. And some of this really is climate dependent, and it's also systems dependent. So we've had projects where the building owner, the developer, through their maintenance staff was just like, didn't want to hear anything about variable refrigerant flow, heat pumps, nothing. Just no. So, okay, if you're dealing with that, then you just keep asking questions and have the conversation. And then we've had other projects where the engineer and the architect and the developer, building owner, everyone, they get together and they talk about, well, what do we want to see for this system? What system's going to have like lowest maintenance for us? What system's going to be the best for our employees to be comfortable and for the people to work here to be comfortable? And then once we can have those kind of conversations, then we can look at the system and start to figure out if it's going to be ducted air handlers or ductless air handlers, for example, or ductless, fan coils where the air is just recirculated within the space. So if you're kind of doing that system like that small winery, we showed the picture of where they went with the Samsung brand. We're brand agnostic, but that was the brand they went with for their heating and cooling, the variable refrigerant flow system, because that particular brand does make a small 6-ton VRV systems. And so with the 6-ton system, it could cool off the whole place, and then they could have a separate conversation on how do they want to bring the fresh air into the space. And so when those small systems like that, when it was decoupled, then they can have better control over the ventilation and ventilate it only when they need it. And so I don't know if you attended the class we did on the heat pumps, but part of that solution was also to just use a separate mini split for their conference room with its own independent sensor and outdoor air ventilation. So it was just super simple and did it for that one space. And then the variable refrigerant flow system, that was the bigger one, then could do all the other offices, private offices, the labs, and the group offices. And then the indoor air quality on that, the amount of air they needed for each one could be fine-tuned with its own system. So
Yeah.
I don't know if that helps, but it's
Yeah,
a conversation.
Right.
Really.
No, but that's really good because it also just kind of reminds us that a lot of those decisions, you know, there's not a set best practice. It's going to depend, like, oh, we've got a lot of people in this room. We need a lot of air changes, and therefore we go one direction versus this one, which gets only occasional big uses and then is otherwise really sparsely occupied, et cetera. And so that would inform, you know, and then of course the temperature piece of it as well. So thank you. Yeah, super helpful. I think those
And
were mostly the questions that came up during the chat. I don't know if anybody else has other ones that they want to bring to the group, or suggestions or comments. This is always a good way to hear what everybody else is doing with their practices.
Yeah, I saw something, I think, in the chat real quick. Someone was talking about using small trickle ducts to bring in or make a balanced ventilation. So if you have exhaust fan system as the primary way to introduce fresh air, for a while it was kind of popular to use, and Rensar was one brand where they were promoting that, because it's a system used in Europe where you could have small trickle ducts or even part of a window frame and fit above the window frame, and it would just open and just bring in that fresh air. And part of that whole system functioning the way it was designed is it also assumed that the outdoor air was of better quality than what you had indoors, right? So it's kind of like opening your window. So it's unfiltered air. It just comes in. It's just mechanically induced ventilation instead of just, you know, trying to open opposite windows to get the cross flow. And I haven't heard too much about that for a number of years now, because I think because wasn't that easy to just turn it off. Just to stop the airflow through the trickle ducts. And so if you could turn off your exhaust fan and then you still have that. So I mean, you're kind of just back to, are you using the walls or your leaky envelope to filter the space? You're trying not to, you're trying to control it. So yeah, if you control it with the trickle duct, then you're forcing it to come through a trickle duct versus forcing it through the cracks in your wall assemblies. And then you can potentially, depending on your climate zone, get into condensation issues if you have big diurnal swings, you know, daily, night, like I do up in North County of San Luis Obispo. You know, it was 26, 28 degrees, and then it shoots up to today it's going to be 77 during the day. So, I mean, that was a huge diurnal swing. So there's always the potential for my leaky envelope to have condensation in the assemblies.
And David has raised his hand. Go ahead, David, and unmute, because he was actually had kind of a clever trickle from a sealed crawl space. So do you want to clarify kind of what or if you had a follow-up question, David?
Yeah, I just wanted to share some detailing that I've worked out as a result of the Santa Cruz fires. And the one thing that I try to avoid are the intumescent treated wildfire vents for things like attic spaces and crawl spaces. They're incredibly expensive. There's the expense of installing them as well. And so I have certain detailing that I've used to eliminate all attic ventilation. And the other thing I do is I use what's called I think it's called referred to as an unvented crawl space. So there are no crawl space vents. And so what I do is I have a very, very small CFM exhaust fan that runs 24/7. I did an 1,800 square foot house, and it was like 21 CFM was the calculated CFM for that big of a crawl space. And so it's really hard to find exhaust fans that are small enough to work. And then all I'm doing is I'm venting through one intumescent vent. The one I used was 12 inches by 12 inches. So it creates the least amount of exposure to ember intrusion in the crawl space. But the only way I can do the makeup air is to basically just, it's like putting a small register in the floor of the house. So that 21 CFM of exhausted area is pulled from the heating area, which is just another hole in my conditioned envelope. So that was 3 years ago, and I've learned a lot about different types of ERVs that some of them you highlighted today. So I might rethink that. I'll still have the 12 inch by 12 inch intumescent vent, but maybe I can go with an ERV or even an HRV that cycles between exhaust and intake to just eliminate that hole in my heated envelope. So I was just wondering if you had any thoughts on a different way of providing the makeup air for the crawl space venting that didn't involve just basically pulling conditioned air out of the heated space.
Yeah, I think you're on the right track. I mean, so kind of climate zone dependent. It's when our climate zone's right on the coast, they're pretty mild. So it's, how do I put the slower the air movement is through your heat exchanger core, then the more efficient they operate. And sometimes you don't really have control over that because it's set up with the system you buy. So maybe looking for one that does have the high efficiency or low CFM, and it would temper the air so that you still have a hole in your envelope because you're bringing in supply and you're sending air out, but at least it has a chance to conserve some of that heat, and then it tempers the air coming in. And you can, during wildfire, if you do go with the more expensive system that are monitoring for the PM10 and PM2.5, at least it would alert you to when it's noticing a certain amount of that getting past your filters and into that system, and you can just choose to turn it off at that point. But yeah, I think these are all really good questions for us and wildfires and what we're seeing right now. It's tricky, and it's hard to imagine that many of the houses are going to be so hermetically sealed that you could still have a good supply of oxygen and get rid of the CO2 and other pollutants at the same time we're dealing with wildfires. That's tricky. But carbon filters, the HEPA filters, are really like looking for the PM 2.5 and PM10 type filter, or better, do higher than the MERV 13 filter. HEPA is higher than a MERV 13 filter. The higher the filter, the more efficient it is. Yeah.
All right.
But as our houses get tighter, as our buildings get tighter, then we're noticing We need to introduce the air, outside air intentionally and have control over it. And that's probably one of the biggest takeaways. Intentionality and control.
Great. All right. Any last questions, comments before we sign off for the day? All right. Thank you, Chloe, as always, for managing all the logistics, and we'll see a lot of you next week. Thanks,
And
everyone.
thanks, and thanks, David, for the contribution and everyone else. Thank you.
Bye.
Bye.